So our problem, we start with a 25 kilogram box. It's being pulled 300 newtons at 38 degrees. We want to find the acceleration of the box. It also tells us the coefficient of kinetic friction is going to be 0.13. And so in order to start this, I'm going to draw all the forces that are acting on it, and that's going to help us get started. So this is what it starts with. Now in purple I'm going to start adding on. So it's being pulled at an angle, so it's going to have an X component and a Y component. So this would be force, this would be a force applied, so it would be force applied in the X direction, force applied in the Y direction. Then we have the box. Box has mass, so it's going to be accelerated by gravity. So we have Fg. Then opposing Fg is going to be your force normal. And then of course we're going to have friction going backwards, which would be force of kinetic friction since it's going to be moving. So what we're going to need to do is we're going to need to find all these forces and use them in order to find out what's happening with this box if it's accelerating. Notice 300 newtons. This is an XY coordinate system. This is your Y axis. This is your X axis. Notice how this is off at an angle. So once we solve for force applied in the X direction, force applied in the Y direction, we no longer need this 300 newtons. We will no longer use it. We will only use things that are moving in the X direction or the Y direction. So let's start that. We're going to first write down our givens, and then we'll go from there. So given 25 kilogram box is a mass. We know 300 newtons force applied. That's right now in the resultant, so the XY direction. So just to know, that's in the resultant direction. We know 38 degrees is our theta. We also know acceleration in the Y direction is always gravity, so we have negative 9.81 meters per second squared is acceleration in the Y direction. Our unknown, we're going to solve for all these forces. You'll actually notice there's some that you can solve for before others. I usually like to start with force of gravity and then I just go clockwise. So let's start with Fg is our first unknown. Then we're going to go to force applied in the X direction, force applied in the Y direction. Then we're going to do force normal and then force kinetic. We'll go from there. So the equation for force of gravity, the box right now, it's being accelerated by gravity. So we're just going to do force of gravity equals mass times acceleration in the Y direction. If you want to write subscript Y, you can. You don't need to, but you can. So we're going to sort that. Force of gravity. Actually, you don't need to sort it. You just plug it in. So we're going to substitute. Mass is 25 kilograms. Acceleration is negative 9.81 meters per second squared. So Fg is equal to negative 245.25 newtons. So we have Fg. Okay, so this one is done. Now we're going to find force applied in the X direction. Notice it's a triangle. It is adjacent to theta. So I'm just going to use cosine. And so equation is going to be cosine theta times hypotenuse is going to equal our adjacent side. So to sort, so we already sorted it. Cosine 38 degrees times 300 newtons is going to give us that adjacent, which is force applied in the X direction. And it is going to equal 236.4 newtons. Okay, so we have Fg, Fax. Now we're going to find Fay. Notice back here, it is opposite. So I'm going to use SOA. So SOHCAHTOA, I'm going to use sine. So sine 38 degrees. 38 degrees times 300 newtons. And when we do that, for force applied in the y direction, we are going to get 184.7 newtons. Okay. So I got these three. Now to get force normal, we have to think, okay? Is this box, is it going to move in the y direction if we're pulling it? Probably not. It's probably just going to slide. And so it's not moving in the y direction. So actually one of our givens could be that the net force in the y direction should equal 0 newtons. So what that means is when you add all your forces in the y direction, it should equal 0. So what I'm going to do right now is I'm going to change our box, because you know how it's kind of messy right now. I'm going to change it so there's an x box and a y box. What I mean by that, here's our our y box. So here's our y box, put y by it. Force of gravity is acting on it in the y direction, and then the force normal. And then also the force applied in the y direction. So there's three forces acting on it right now. So Fg, we have force applied in the y direction, and we also have force normal. We add all three of these together, it has to equal 0. So from that, we get the equation Fy equals Fn plus Fg plus Fay. Okay? Just all the forces in the y direction, they all have to add up to equal the force, the net force, or the total force in the y direction, which we know is 0. So we have 0 newtons equals, we don't know force normal. We know Fg is negative 245.25 newtons, and we know that Fay is 184.7 newtons. So when we solve for force normal, essentially you're going to take negative 245.25 newtons, and you're going to add it to 184.7 newtons, and for force normal, we're going to get 60.55 newtons. Okay, so that's our force normal. So now we got Fg, Fax, Fay, Fn. Now we can solve for Fk. So to solve for Fk, all we're going to do is the equation mu k. So here's our equation. Mu k equals Fk over Fn. To sort it, we'll just take mu k times Fn equals Fk. And then we're just going to substitute in. We know mu k, it gives it to us in the problem originally, 0.13 times our force normal, which we solved for right here, 60.55 newtons. And we're going to multiply those together. This will give us Fk, which is going to be 7.87 newtons. Okay. So now, that was our box in the y direction. Now I'm going to do a box in the x direction. And so for our box in the x direction, if you look at it, we have Fk, Fax. Nothing else is directly in the x direction, going along this path. Okay, this is going diagonal, so we can't do that. It has to be going horizontal. Only these two are going horizontal. So our box looks like this. We have Fk, which is 7.87 newtons, going left, because that's what it has it in the picture. And then we have Fax, which is going right, and it is 236.4 newtons. And so when you add those together, this will be negative because it's going to the left, so 236.4 newtons. Hey Josh.
Hey.
Minus 7.87 newtons. We are going to get 228.5 newtons is the total force in the x direction. See ya. Now that we have that, we're going to use the total force in the x direction. Essentially what that means, the total force in the x direction, we just have a box now, and all we know is that the force in the x direction is 228.5 newtons. We also know the mass of the box, so we're just going to use F equals ma, and using F equals ma, we'll solve for our acceleration in the x direction, because this is Fx equals m, acceleration in the x direction. Divide by mass, divide by mass. So we have 228.5 newtons divided by 25 kilograms, we will get 9.14 meters per second squared for your acceleration.